Hey guys, so this is 8.4, more on quadratic equations. And we're not going to cover everything in this lesson, just the first two examples, because I thought they were kind of useful. So for the first two examples, we're going to talk about using the discriminant and factoring. And so that goes back to the quadratic equation that you learned in the beginning of the year. And we're also going to talk about writing quadratics if we're given solutions. Writing the general equation. So let's start with this. So let's consider our function again, our quadratic function, ax squared plus bx plus c. So one cool thing is if you know the part in the quadratic formula that's the plus or minus b squared minus 4ac, remember that's called the discriminant. If the discriminant, the part underneath the square root, is a perfect square, like 49 for example, then if you took the square root of that, you would get a whole number. Okay, so like for instance, the square root of 49 is 7. So you would get a whole number. And then the solutions then to the quadratic equation, if you set it equal to 0, they end up being rational. Okay, remember rational means that they can be written as fractions. And so if that's the case, then they can be found by factoring the quadratic, okay? If you don't get a perfect square underneath here, then this quadratic is considered prime, meaning you can't factor it. You'd have to use the quadratic formula and you would get, things that have, like, let's say square root of 5 or square root of 2, things that aren't rational. Okay, so we're going to do an example here just to figure out if we can factor this equation, this quadratic. Let's see if we can factor it using this idea. Okay, so let's just consider this one. This one is actually example A. There's also another example on this one. And so again, identify A, B, and C. So A equals 6. B equals 1 in this case, and C equals negative 15. And then we're going to check to see if the discriminant, we actually don't even need to do the square root, but I'll just write it anyway, but the discriminant, let's see if the discriminant is a perfect square. So 1 squared, right, we're going to do b squared, so 1 squared, and then minus 4, and then a is 6. C is negative 15. Okay, so this ends up being, and I'll just simplify it down here, 1 plus, and then we end up getting 360 when we multiply these together. And so 1 plus 360 is 361. Okay. And I know most of us don't know that that's a perfect square, but it actually is. The square root of 361 is actually 19. So this is a perfect square, and you can check it on your calculator. If you're not sure whether it is, just check it on your calculator and see if you get a whole number. And so because this is a perfect square, the discriminant is a perfect square, then I know I can factor this by hand. Now, this isn't a nice one to factor. You'd have to use, again, one of the terms, either splitting the middle term. They also call that the AC method, where you multiply these two together and then you try to factor by grouping. But it can be done. Okay, you can also do like a trial and error thing where you try to guess what the two leading terms are, whether it's x and x, or like a 1x and a 6x, or you can try different combinations. But so this one can be factored. So now let's look at B. So B ends up being another one of those where A does not equal 1, it equals 5. So, and again, usually the ones that, when you look at these, like if you see that the leading term is not a 1, that makes you want to try this method, honestly, so that you're not just guessing for a very long time and not getting anywhere. So we're going to try the discriminant again and see if we end up getting a whole number when we take the square root. So there's A, B, and C. That's a plus sign. And here we go. So B squared. So that's negative 3 squared minus 4A and C. So this ends up being 9 minus 40. And you can already tell we're going to have a problem here, actually. You can already tell we're going to have a problem here. So we actually end up getting a negative 31, and that's not good anyway. If we take the square root of that, it ends up being imaginary, so and not a perfect square. So that would be a no on this one. This one's prime. Okay, you can't factor this one. The final thing I wanted to talk about was writing a quadratic with given solutions. So you can do almost like a reverse factoring method on this if you're given the solutions. Recall basically like if you had, let's say, x plus 5 times x minus 2. Let's say that was your quadratic, and you tried to set them both equal to 0 to find your solutions, right? You'd end up getting a negative 5 here. And if you added 2, you'd end up getting a 2 here. So they're going to give you these numbers here, and they're going to ask you to go backwards, okay, and write a quadratic, okay? That's all they're going to do. So we'll do example 2. We'll just do a couple of those, and then we'll be done. So example 2, they say write a quadratic equation that has each given pair of solutions. So the first one's nice and easy because they're integers. So again, think back to this example here. When my factor was x plus 5, my solution was a negative 5. So imagine then, again, if you think about this, if it was a positive, you would write it as x minus that number. So this one's going to be x minus 4, okay, times x plus 6. All right, and so that's really as easy as it gets there. You can kind of see too that if you were to set that equal to 0, right, you'd get x equals 4, so that matches, right? So it's the opposite. When you write it as a factored form, it's the opposite sign, okay, just so you know. And so I'll just show you this one too. If you subtracted 6 from both sides, you get a negative 6. That matches, right? So I think they also might want you to multiply it out. If you were to multiply it out using FOIL, it would just be this. Okay, so they just want you to write the quadratic again for that. B is a little bit more challenging because you're given square roots. And so that's not as nice, but again, just do the opposite of what you see here. So if you see a minus root 2, you're going to say x plus root 2 for that one. And then this one's a positive, so you're going to say x minus root 2. And then you could multiply these out, and it's a kind of a weird one, but you could do it. Recall that this is a difference of squares, so when you do the inner and outer terms, they're going to cancel. So I do what's called Florida, like I used to say, but so we do first terms x squared. When we do the last terms, this is minus, because of this minus here, root 2 times negative root 2 is negative root 4. And remember, the square root of 4 is 2, so this is x squared minus 2. So there's that. And then the final one is here. This is a negative 3i and a 3i. And so again, just don't let that bother you. Just remember, just think of the opposite. If you write it as a factor, it's x plus 3i for that one. And for this positive one, it's x minus 3i. And then you just have to FOIL that and see what you get. So again, this is the difference of squares again. You've got conjugates here. So we're going to do Florida again. So first times first is x squared. And then again, inner and outer terms cancel. And then we end up with, we do the last terms. It's positive 3 times a negative 3, which is negative 9, I squared. I times I is I squared. And then recall from the beginning of the year, I squared is equal to negative 1. So this is x squared minus 9 times negative 1. And negative 9 times negative 1 is positive 9. So there you have it. Those are the examples, the only ones you have to do from this section.